welcome back. In just about every C program, you're gonna have brackets. And specifically these curly brackets. You have them in our for loops, we have them in our while loops, and we have them when we define a function. But what if we use these brackets outside of that? Let's take a look at that. Here we have a toy program and it prints hello world. It defines and initializes a int of I. It increments I. It prints I and then closes. Now, are these curly brackets doing anything? And will this program even run? Let's just add an extra space here just to show that these curly brackets aren't associated with the printf. They're just independent. I just have that printf there to show the order, and that'll be relevant later. So let's go ahead and make this, and this br2 will get to at some point. So we run br1 and it prints hello world, then it prints I, which is 11. Now, what if we want to print I again? Let's see. Let's increment it again. And let's see. Go ahead and pause the video and let me know what you think this line will produce. Okay, you have your guesses. We'll go ahead and make this again. And if you guessed there was going to be an error, you were correct. Now, why is that? So everything that happens within these brackets are self-contained, but they are and they aren't. They're self-contained. Anything that's defined in here cannot be accessed outside of the brackets. But let's see what happens if we go ahead and comment this out and put it up here. Now, what do you think both these printfs will print? Again, pause the video and go ahead and leave your guesses in the comments. And let's see what happens. Will it even be able to be compiled? Yes. And we run it, and we get the 11 and the 12. And so this is similar. This I now is being treated as a global of some sort, global within main. So if this I was described here, it would be global throughout the scope of the program, but now it is global to whatever in here. So this is why you can sometimes define, well, you can always define it, but you can define an int before a for loop. So you can always say int I outside the for loop and then just initialize it to the value you want. Then later on, this I here would start off with whatever the value was when this for loop ended. If this was a program, this is just some garbled code. So that is what is happening here. But now, what happens if we wanted to define a function within the function of main? What would happen then? So here is a program. We're defining this function doStuff. Again, it's initializing. It's basically doing the same thing as the other program. It's initializing I to 10. It's printing it. And then it's printing hello world. Or is it? Is it going to run here in the code? Or is it going to run here in the code? And that is why I have this hello world, just to show the order of which things are running. So we already know it compiles because it's part of that make file. So if you already saw that, then you already know that this is going to compile. But when we run it, what's going to happen is this line going to print before or after the hello world, or is it going to print both times? What do you think? So we run br2 and the hello world line prints, and then the I equals 10 line prints. Now, why would we want to do this? There is probably reasons for that. If you want to encapsulate, which is something you normally hear in C++, but it's basically what you want to do is you want a piece of code that is going to define variables and not use it outside of its scope. And that also makes you wonder what is happening when you have a for loop. Go ahead and subscribe, and my next video is going to be on what's happening inside of a for loop. Thank you for watching. You have a great day.